My name's Arabella Darlington. I'm a Year 10 student from Brisbane, Australia, and I have been obsessed with outer space since I was like 6 years old. I went to the NASA exhibition for my 12th birthday, I learned everything I could about it, and I think that I have a really good idea here, so let's get into it. So the problem here is, how will our astronauts survive this 3-year mission to Titan without being affected by dangerous radiation? Now, radiation is measured in millisieverts, and 1 millisievert is equivalent to about 3 chest x-rays. Now, in deep space, astronauts are exposed to large amounts of radiation constantly, and it's between a range of about 0.12 to 0.228 millisieverts per day. Now, that would be equivalent to around 315 millisieverts for the entire trip. Now, current health guidelines say that no one should get more than 1 millisievert per year. The health effects of excessive radiation include an increased risk in cancer, sterility, genetic mutations, birth defects. So it's safe to say that 315 times above the recommended dose is not a good place we want to be at. So let's talk about the solution. So the solution has 2 basic parts, and the first one is an external shield. So we want to protect the astronaut who will be in a cabin. Now, the best material for some kind of shield like this is hydrogen, but it's unstable as an element. So the next best option would be a high density polyethylene enhanced with 5% boron. It will provide excellent protection against the radiation while also being light, inexpensive, and easier to work with than liquids like water. Now, for an added layer of protection, gadolinium oxide will also be mixed with a polymer and coated around the spacecraft. Now, this is essentially rust, but studies have shown that it can reduce radiation by an average of 225%. Now, part 2 of this solution is medicinal. So there are several drugs that the astronauts can take that will reduce the risk of radiation exposure and treat them in the event that an exposure does occur. Potassium iodide will temporarily shut down the thyroid gland and reduce the health risks that otherwise the thyroid would endure. Now, 2 other drugs will be on board in case of an emergency. The first, Prussian blue, which will remove radioactive thallium and cesium from the body, and the second, DTPA, will bind to radioactive plutonium, americium, and curium, and allowing it to leave the body faster, also reducing these health risks. So these things on their own wouldn't be enough, but by combining them, we do have a viable plan to protect our astronauts from the deadly space radiation. Thank you for listening, and I really hope you'll consider me for the scholarship.